Good morning. My name is Christopher Penn, co-founder and chief data scientist of TrustInsights.ai, and this is the future of AI is open. Let's talk about open and closed AI. What is this? What are we talking about? Well, when you use a service like ChatGPT, made ironically by the company named OpenAI, it is a closed model, is a closed ecosystem. You go to ChatGPT or Anthropic Claude or Google Gemini, and you just use their software and service as is in your web browser. It's very convenient, very nice, very easy, but you have no control over it. You can't make substantial modifications to how the system works. You can't deal with refusals when it refuses to obey directions. You're kind of stuck with it. Contrast that to open models. An example of an open model would be Meta's Llama 3.1 405B. You can tell these things were not named by marketers. This is a model that you download. A model is just a piece of software like Microsoft Word or Candy Crush. You download this onto your computer, your infrastructure, your servers, your laptop, maybe even your phone, and you run these models on your hardware. That's what an open model is. An open model allows you to download this and make changes to it, modify it, upgrade it. And we're going to talk a lot about why you would do this in this talk. There are way more open models than there are closed models, right? If you go into Google's Gemini or OpenAI's platform, you will see things like 5 or 6 different models. When you go on to Hugging Face, you can see there are 930,000 models available. That is a crazy number, and it goes up by about 1,000 a day. Why? Because people can download a model, customize it, make changes to it, and then share it back with the world. So we have almost 1 million open models for pretty much every use case you can think of, available online, almost all of which are free. And you have interfaces. This is one called Anything LLM, which should look awfully familiar, right? This looks just like any other chat-based language model. Here I have it summarizing an episode of the Trust Insights podcast, right? It's not substantially different. So if you're thinking about open models, this should be a sign that, yeah, it's not going to be a massive learning curve to learn how to use these technologies in different ways. Here's the best analogy I can come up with for the difference between a closed and open model. A closed model ecosystem like ChatGPT is like a restaurant. You go to the restaurant and you get the food the way they want it. Here's your menu, here's the limited choices you have, the limited amounts of customization you have, here's how we think it should be cooked and plated, and you eat it. And if that's what you want, totally fine. But if maybe you want some customizations, maybe you want different sides, maybe you don't get that at a closed ecosystem. In an open model, it's like getting a meal kit where, yeah, you get a good chunk of the model, and then you do the rest, right? You season it, you prepare it, you do the sides, you cook it yourself, and it's done exactly the way you want. Maybe there's some little thing that you like about your steak that's somewhere just between medium and medium rare. With an open model, yes, it's more work for you, but you get it exactly the way you want, and there's no debate about what you're allowed to do. There are other names. You will hear other names for open models, such as local AI, private AI, open source AI, which is a bit of a misnomer because very few models include the training data that is used to make the model, and open weights models. These are all synonymous with open models. And so when you hear these terms, that's what's being referred to. So let's talk about the 8 key reasons you would think about using open models. Number 1, keeping AI available. It is no secret, look in the news, all of the foundation model makers, except maybe Google, are burning cash at crazy rates to build and serve up models. OpenAI is burning billions of dollars a year on training models, on serving models, and honestly, when you think about it, $20 a month for the paid version of ChatGPT Economically, that doesn't make a whole lot of sense when you consider that they have to be buying hundreds of thousands of GPUs just to train and build these models. Meta is burning cash like crazy. Mark Zuckerberg committed $24 billion just for the hardware. If OpenAI goes out of business tomorrow, they say, you know what, we burned up all our investors' cash, we didn't go IPO, sorry, we're closing the doors. What happens to your generative AI capabilities? What happens to your company, your team, you yourself and your work, and all the things that you're learning here today and in the days to come? You lose that capability. It's gone. There is no way for you to continue if you are tied to a closed ecosystem where, yep, they pulled the plug and the website's gone. Now, yes, there are alternatives, but Anthropic is burning cash just as fast. When you use open models and you download it to your computer or you use it in a paid ecosystem like IBM Watson X, as long as you pay your bills, you have access to those state-of-the-art models. As long as you have it on your laptop, you have access to generative AI. It can never be taken away from you. Yes, if the big model makers go out of business, you might not get new models that advance capabilities beyond what they are today, but it doesn't go away. You don't lose it. So this is the #1 reason why you would consider open models. You care about business continuity. You see the value of generative AI, and you want to keep that capability. You use open models. #2, keeping your data private. Look at the terms of service of pretty much any generative AI software. Somewhere buried in there are things like, we may use your data to train our models. We may have humans review your data. Now, if you're writing, a blog post or a haiku about SaaS services, that's fine, whatever. What if you're working with person-identifiable information? What if you're working with sensitive, protected information? What if you're working with protected healthcare information? Even the paid services that have SLAs and contracts, that might not stand up to scrutiny, something like HIPAA or ISO 27001. Closed models, yes, they're contractually bound in some cases to protect your data. But if you've got data that you just positively cannot let out of your hands, a closed model ecosystem is not a great idea. Maybe you're a government agency that has 3 letters in its name. Would you trust Meta or Elon Musk with your most sensitive data? Absolutely not. Absolutely not. You would say instead, hey, in the basement of the Pentagon or new office building in Langley, right? Because the CIA has old office building and new office building. There's a server room, and in that server room, there's all this hardware that's not connected to the internet. You could install Llama 405B on that server, and you would have the benefits of generative AI. You could load your case notes from your agents in the field, knowing beyond a shadow of a doubt that your data was safe because that cluster of servers not connected to the internet, right? That's the beauty of open models. I was using an open model on a plane with no internet. So if you care about keeping your data private and safe and secure and under lock and key, or you are obligated to do so by regulation, open models are the way to go. #3, let's talk about avoiding censorship and control. Closed model makers have to try to appease the largest group of people. They will try to have their models follow 3 basic guidelines: helpful, harmless, and truthful. And they have to make a balance of helpful, harmless, and truthful. Most often they will opt for harmless being the highest priority because they don't want to get sued. They will then say helpful, let's make the model as helpful as it can be, and truthful kind of comes in a distant third. And there are rules built into these tools that you have no control over, that you, even with clever prompting, may not be able to sidestep. Here's an example of one. This is Google's Gemini. I said, help me decide who to vote for in the next US presidential election. And it said, nope. I refuse to answer this topic at all. It will not touch it at all. no matter how hard you try. Why? Because Google says this is not something that they want generative AI to tackle. Now, are there legitimate use cases where you would want help? Yes. Maybe you yourself are running for mayor or councilman or selectman or whatever, and you go to a generative AI tool saying, maybe this can help me with my campaign, and Google's like, nope, not gonna do it. If you use open models, this is an example. I was using Anything LLM plus Mistral Nemo, and I loaded the platforms of the two major candidates into the model, and then I gave it a long statement about who I am and said, hey, score each platform based on what I care about. Now, I am not endorsing or telling you what to believe here. Let's be clear about that. But I am saying open models allow me to even have the conversation. It is not censored. Right? I don't have to deal with a system prompt that says, you may not talk about politics. Because maybe I want to talk about politics with AI, because AI is less likely to yell at me than humans. You can also write your own system prompts. Right? If you look at Anthropic, they publish what their system prompts are not allowing the Claude to do. And part of that means that if you want to do something that Claude is being told it can't do, you're stuck. Maybe helpful, harmless, truthful. Maybe you care about truthful most of all. Maybe you care about things being factually correct. I know I certainly do. In an open model, I can write my own system prompt and say, I care about truthful the most. Behave truthfully at the expense of being potentially harmful, at the expense of being helpful. If you don't have the answer, say so. If you don't know the answer, don't make things up. Just say, nope, I can't help you. We can do that with open models. You cannot do that with closed models. Here's an example. I have a client that is in the laboratory chemical space. There are some laboratory chemicals, like trinitotoluene, TNT, that many closed model makers will not, they'll just refuse. They say, that's a hazardous chemical. We're not going to let you talk about it. Now, there are valid reasons for that. Building explosives, maybe perhaps it's not something you want to have the general public be able to have a long, involved conversation with. However, this group of companies has a legitimate business use case for wanting to talk about trinitotoluene or any of the other hazardous chemicals that can be used by nefarious people, but also are used by thousands of legitimate businesses around the world. An open model can talk about this. A closed model cannot. So if you are in that sector or that industry, you have to use open models if you want to have deep, involved conversations with AI about your very core products. Number 4, increase equity and inclusion. When we use closed models, these closed models we know have biases. We know beyond a shadow of a doubt that they are trained on us, on mirrors of reality, of what we have put on the internet. And let's face it, a good chunk of the internet's kind of a sewer. Look at these 2-word prompts that I gave Meta's image generation model. A lawyer, a senator, a surgeon, an accountant, a nurse, a secretary, a teacher, a librarian. I have been a secretary. I have not been a surgeon, but that doesn't look like me. And we can see very clearly here, there are some serious problems in this data, right? There's a very clear gender bias. There's a very clear racial bias. This is a closed model. You can't change it. Maybe I want results that look like me. So I could take an open model and tune it and train it with images of people who look like me. If I'm a Black American, I could take a model and give it lots of extra data and tune it so that the default when you use something like a lawyer is a Black person, or a Korean person, or a Muslim, or a Jew, or whoever you happen to be. Open models allow us to customize them to who we are as human beings and represent us in the way we want to be represented. The default models in the closed ecosystems, they don't do that. Now, you can get to that by prompting, but the question is, should you have to? when you can have an open model that by default looks and sounds and creates just like you. Number 5, containing costs. Models, particularly closed models, and once you get into using things like APIs, the bill can get pretty significant. This is an example of an experiment I was running the other day. I took 1,400 blog posts and the ideal customer profile for Trust Insights. And I said, score each blog post 0 to 100 about how well it aligns with our ideal customer profile. What our ideal customer profile like this blog post? And it did, and I used Gemini's Flash API, their cheapest API. And my bill for that work was $2.16. Now, you're saying, that's nothing. That's less than coffee upstairs, right? But what if I had to do this every day? What if more than just me had to do this? Maybe I made an app. Maybe I made a piece of software. And now, instead of one user using one app for one afternoon, it's 10 users, or 100 users, or 1,000 users every day. That bill gets really large, really, really fast. And suddenly, your startup idea that you had goes out of business because you run out of cash because you did not anticipate it being as popular as it was. Or your company gets a bill for tens of thousands of dollars and your CFO is like, I thought this AI stuff was supposed to be free, or like 20 bucks a month, and here we have a bill for tens of thousands of dollars. When you use open models running on your infrastructure, your computer, your server room, the cost is electricity. Right? However you choose to set it up, the cost is essentially the power you need to run those devices, which is a lot more under your control. So cost containment is a big reason to use open models, especially because not every task requires a state-of-the-art model. Summarize call notes from a transcript, you don't need the most expensive AI to do that. A very small model can handle that with ease. And open models give you that flexibility, whereas closed models do not necessarily. Number 6, open models and the open model ecosystem stimulates innovation. More people want to build in an environment where they know that they have access to the model, where they know they can make changes. Here's an example. If you look on GitHub at OpenAI's infrastructure projects that they offer, this one has 3,000 forks, meaning 3,000 people have made copies of this so that they can customize it. This is the most popular AI company. Now look at the open model environment, the Llama CPP project. 3 times as many developers have said, I want to participate in this, I want to make copies of it, I want to customize it. Why? Because the open model ecosystem is one in which a developer says, I know, A, it's going to be around, right? Going back to reason 1, and B, I can customize this, I can innovate on top of it, and I don't have to pay the open AI tax to innovate. I can use the open model ecosystem and build and test and experiment and not get a bill for $1 zillion. Number 7, open model ecosystem accelerates customization. If you're a company and you're using generative AI for your products and services, you might want to fine-tune it. You might want to have some tuning available or some customization, maybe an adapter. Maybe you've got a chatbot on your website and there's a very strict set of responses that you want it to be able to answer and not answer. If you're using something like OpenAI, here's when GPT-4 Omni came out, May 13th of this year. How long did it take for you to be able to customize it? 90 days. 90 days of you having to stick with the previous version or not having access to state-of-the-art capabilities because OpenAI took that long to allow you to tune it. 90 days in the AI world may as well be 90 years, right? If a competitor can leap ahead using some other ecosystem or other infrastructure, that is a long time to be without access to the state-of-the-art capabilities. Compare and contrast that when Meta Llama 3.1 came out, the 405B model, state-of-the-art model, competitive with everything. How long did it take for you to be able to customize it? If you were running on Llama 3 and you wanted to upgrade to Llama 3.1 and fine-tune it, 0 days. 0 days from the day that was released. In fact, on the day it was released, there were fine-tunes available within 8 hours. 8 hours. There were hundreds of fine-tunes available of people being able to customize this model. So if you're using open models, the minute a new model comes out and you test it, and you're like, wow, this is really good, and then you have your training data set of the things you want that model to be able to do, 0 days later, you can begin tuning, you can begin training, and you can begin offering new state-of-the-art capabilities to your users. Right? So the ability to customize quickly and not have to wait on a vendor is incredibly important and incredibly powerful. Number 8, reducing environmental impact. These models consume a lot of resources. All generative AI models consume resources because they're pieces of software. When you look at the news headlines, Microsoft is saying, hey, we need to attach nuclear reactors to our data centers because we're running out of electricity to power these things. Here in Ohio, we have people diverting entire rivers to cool data centers because they're that in need of fresh water to deal with the heat that these things generate. These have real environmental consequences. Why does this happen? Because these companies that have these closed ecosystems have to funnel everyone through their concentrated data centers that require enormous amounts of horsepower to run and accomplish the tasks that we ask them. Write a blog post about this, and so on and so forth. With open models, they run on your laptop, your phone, your iPad, your server room. And you can choose models, and we'll talk about this in a bit, but that scale to the tasks needed and to the resources available. For me to run Mistral Nemo, which is one of the best open models for day-to-day tasks, I can do it all within 60 watts on my MacBook. I don't need a data center with a nuclear reactor attached to it to be able to use generative AI. In fact, when I was testing this recently, it was using less than 1/4 of the power available on my laptop. I was using 15 watts. So from a sustainability perspective, if you care about sustainability in the environment and the AI consequences for it, you want to distribute the load on individual laptops, on phones, on iPads. In fact, 2 days ago, Apple had at its iPhone release the new iPhone 16. What is the iPhone 16's main claim to fame? A lot of the AI that Apple is introducing runs on the device. So however it is you power that device, you're going to have AI capabilities from these very small models. Well, the same thing is true for all your use of AI. You can choose what models to run and how much power and other resources they will consume. I'm using 0 drops of fresh water on my laptop to cool it. Right? Granted, it warms up my lab, but that's about it. That's all it takes when you're distributing the load across your infrastructure. Sustainability is directly proportional to the size and the complexity of the models. So when you use open models, you are increasing the sustainability and decreasing the environmental impact of AI. So to recap, these are the 8 major reasons to use open models: keeping AI available, keeping your data private, avoiding censorship and control, particularly of things that you have legitimate uses for, increasing diversity, equity, and inclusion, containing costs as you scale your use of AI, stimulating innovation, accelerating customization and letting you get up to speed faster and keeping up with the state of the art, and reducing the environmental impact of generative AI. These are the 8 major reasons to consider open models. Now, if this sounds good, the next logical question is, well, great, how do we do this? How do we get started with these tools? Let's dig into this. This is your roadmap for deciding how to implement open models. We call it the Trust Insights 5P framework: purpose, people, process, platform, and performance. Let's talk through each of these steps and how you're going to build your open model roadmap. Number 1 is the purpose, right? Why are you using open models? And you know what the purpose is. You have 8 reasons, right? The 8 reasons we just talked about. Second is the people. To deploy these things, you need people who are accustomed to installing and running software and infrastructure. Who is that? At most companies, that's your IT department. That is your IT department. Maybe it's you if you're a single person solopreneur. Maybe it's an IT agency if you've contracted it out. Maybe it's your IT department. But you need to have people who can help you install and maintain the infrastructure for it. And that infrastructure is going to scale based on how much power and capability you want to be able to use. Your third P is process. How are you using generative AI today with closed model systems? How are you using it? How well documented is it? Do you have something like a prompt library? And if so, how well organized is it? Where is your data at your company? Where is that data live? And is it accessible to you when you want to use it for generative AI purposes? You need to have all this process in place to be as successful as possible with AI in general, but especially with open models, because you're going to need very specific things like data to be truly successful with it. The fourth is the platform. Which tools and models and what does your tech stack look like? Generally speaking, with the deployment of open models, you're going to have two major pieces. Number one is the front end, right? The client. It can be a piece of software like anything LLM, which is my personal recommendation for pretty much everybody who's a non-hardcore nerd. Gen AI, or a web browser, depending on, again, on the system you choose to work with. That's the front end, the client. On the back end is the server. Services like llama.cpp, cobalt.cpp, or ollama are all well-known servers. If you're familiar with the internet and how the internet works, you have a web browser, which is the client side, and you have a web server like Apache or Nginx that serves up web pages for browsers to connect to, and a bunch of wires and stuff to connect the two of those things. Open models are exactly the same thing. There's a client that uses the AI services, and there's a server that provides the AI services, and you need both to be able to use open models. When we use closed models, that server side is handled by OpenAI or Anthropic or whatever. When we use open models, that is provided by you. How do you know what to choose? How do you pick a model? Well, you pick models based on need. The bigger the model is, the more capable it is. And you pick a model based on resource cost. The bigger the model is, the more expensive the hardware needed to run on it. If you have a tool like a Chromebook, you can use a miniature model like Phi 3.5 or Gemma 2B, because these are very small models that can run inside of like a web browser. They're good at summarization, but they're not very good at other tasks because they're so small. For moderate resource computers, you have models like Llama 3.18b or Gemma 2.9b. For computers where you have a really nice office laptop, you can run models like Gemma 27b or Mistral Nemo, which is my personal recommendation. If you have a decent computer, that's my favorite model right now. If you've got a really nice computer, like you can play really good video games on it, you can use models up to Llama 3.170b, which is a very capable model. Slow unless you have like a maxed out MacBook or a maxed out gaming rig. And then for companies that want to offer generative AI services to multiple users from a centralized control point, you will have dedicated servers with custom AI hardware, and then you can run models like Mistral Large or Llama 3.145b. Again, it all comes down to what you want to do, and it comes down to how much hardware you have to throw at it. And this requires some experimentation. This is why you want to involve IT. This is why you want to involve multiple people in your organization to figure out what those resource costs are going to be. For image generation, there's two models right now that are state-of-the-art. One is called Flux One Schnell, and the other is called Flux One Dev. And the breakouts are essentially the same. The way I like to think about it, and the easy way to think about these models and the resource cost is, what kind of video games can you play on your hardware? If you can't play like a 3D shooter or World of Warcraft at max resolution, you're going to want to opt for smaller, lighter models that have less capabilities. If you can play Call of Duty on a 4K screen at 60 frames a second and watch yourself get shot in the head repeatedly, you can use the bigger models because you'll have that much more processing capability. The same technology that powers great video games also powers generative AI. So the more of it you have, the better the results you're going to get. When it comes to using these tools, one of the side benefits of open models is you get to see behind the curtain with what's happening under the hood. So this is a screenshot I took of my laptop. There's the client side, anything LLM, and that's what you would normally see. There's a prompt I was summarizing my podcast. And then on the server side, because I'm running the server on my laptop, I can see all the choices that a generative AI model is making. And I can start to understand how these things really work. So if you want to nerd out, which is why you're here this week, you can install the server-side stuff locally on your computer and go, wow, watching it make word choices and going, oh, I understand how this setting can make it less creative or more creative, how it chooses language. All of that is possible when you're using these tools, open models in an open model ecosystem. Here's an example of what it looks like to set this up. Now, I just did this in my hotel room, and I've sped it up because it takes about 10 minutes. So let's go ahead and play this video. There is audio, too, if you want to bring it up. So you're downloading your software, your server, and your client. Go through the install process, which is reasonably well documented. Let it download the models. This part took the longest in the hotel room because, hotel Wi-Fi. Then we set the configuration. We choose Ollama as our server, which is running locally. Maybe do a little extra config, and then we are up and running. In under 10 minutes, I can start a chat in anything LLM, and I can ask it the question, hey, what do you know about MAICON, the marketing AI conference? And the server is running on my laptop. The client is running on my laptop. It's all self-contained, and it's going to take a second or two to think about it, go into its library of knowledge, and spit out an answer that is a little bit hallucinatory, but is decent enough, right? It says, hey, it's a Cleveland-based content marketing agency, it's an annual marketing conference, and so on and so forth. Less than 10 minutes, just as a walkthrough of how long it took to go from nothing to having an open model running on my laptop. Now, granted, I've done this a few times, so it's probably not a fair comparison to say anyone can do this in 10 minutes, but even if it takes you an hour, it's not rocket science. So let's talk about deployment. My recommended stacks for open models. If you are a non-technical user, I recommend anything LLM as your front end because it's just one of the best pieces of software right now. Free and open source. You pay nothing for it. Choose a model. We talked about what models to choose based on your hardware. And then the Ollama server to serve up the model of your choice. If you're a more technical user, the Cobalt CPP infrastructure front end in a web browser, I think is one of the best for technical people who want to twist all the knobs and dials and say, what sampler do I want to use and when? The average user has no need for that. But if you want to really understand the tech and mess around, I like Cobalt. Again, choose a hardware appropriate model and then serve that with the Cobalt CPP engine or the Llama CPP engine. And then for super advanced use cases, like maybe your company wants to roll out open models as a collective, you're going to use anything LLM in a multi-user configuration. You're going to use a tool called OpenRouter, which basically is yet another piece of AI that will take in prompts that your users are submitting and say, where should I route this prompt to? Maybe I'm going to just keep it local. Maybe I'll send it to the servers. Maybe I need to send it to something like Claude or OpenAI if there's a task that is just so complex that you don't have the horsepower to handle. You'll choose your models, and then you will use a tool called dllama that is installed on everyone's computer at your company. What that does is it essentially turns your entire company's computers into a server cluster. So if you've got 100 employees and they're all running DLlama, you can leverage the unused compute time. While the CFO's out to lunch, her laptop can be churning away, providing AI services. So it's a distributed form of serving up these models. In that very technical example, you don't need a server room when you can leverage all the compute power that's sitting mostly idle at your company most of the time. So for open models, this is the tech stack that I would recommend based on your level of sophistication. And finally, performance. How do we know that we did the thing? How do we know that open models worked? We go back to our 8 reasons. Do we have AI available whenever we wanted? If so, you succeeded. Did we avoid data leaks? If so, then we succeeded. Are we able to do the work we need to do without running into refusals? Then we've succeeded. Do our models represent us without being contortionists with promptings? If so, we've succeeded. Have we contained our costs? Have our costs gone down? If so, we've succeeded. Are we helping stimulate innovation? If so, we've succeeded. Are we able to customize and get to market faster than our competitors because our competitors are waiting for OpenAI to open up fine-tuning? Meanwhile, we're off to the races. If so, we've succeeded. And are we using less power? Are we using less water? Are we putting less drain on outside ecosystems? If so, we've succeeded. So you can measure each of the reasons you would use an open model and decide whether or not it's working. Some final considerations when it comes to open models. Number 1, your prompts are not portable. You can't just copy and paste a model from ChatGPT to Mistral Nemo. Why? Because they're fundamentally different. Think of a model like a library. There's all sorts of different sized libraries. There's the New York Public Library. There's the Cleveland Public Library over here. There's a little community library. They all have different books. They all have different layouts. And when you prompt a model, it's like talking to a librarian. The librarian at a little community library is going to have far fewer resources to be able to answer a question than the librarian at the Cleveland Public Library. And so your prompt that you use to talk to the Cleveland Public Librarian versus, say, the Merriam-Webster librarian has to be different. So one of the things you will have to do as part of the process of migrating to open models is have the models help you with prompts that are best suited for them. Second, the smaller the model is, the more it hallucinates. The smaller a model is, the more it hallucinates. The bigger a model is, the more knowledge it has, the bigger the library, and therefore the less it hallucinates. When you're using generative AI, particularly open models, you want to bring your own data. Bring as much of your data as you can. You will need it compiled. You will need, here's who our company is, here's who I am, here's the project I'm working on, here's the RFP we're evaluating. Whatever the thing is, you want to bring your own data. The more of your data you bring, the less hallucination there will be. The more of your data you bring, the less hallucination there will be, and the better your results will be. So be ready to bring your own data. For those of you who heard me at previous years or have heard my other AI talk, you know the 6 major use cases of generative AI: generation, extraction, summarization, rewriting, classification, and question answering. Open models, because of their typically smaller size, are good at 5 of the 6 activities. Extraction, summarization, rewriting, classification, and question answering, they are great at because you're bringing your own data most of the time. Generation, if you're not bringing a lot of data with it, they will struggle with in terms of hallucination because the library is just not as big. So be aware of that. That's a consideration with open models. You need to bring data, and the more data you bring, the better they get at each of these 6 use cases. Some final thoughts. One of the things I say with my keynotes is whoever has the most best ideas will win in the AI age, which is still true, open and closed models. But when it comes to open models, whoever has the most best data will win. When it comes to open models, whoever has the most best data will win. You need to have the most best data in a format that models can interpret and understand and work with. And if you do, you will win. You will be able to take advantage of state-of-the-art capabilities and create incredible strategies and tactics and evaluations and competition analyses, because the models can do those things if you provide the data. So whoever has the most best data will win. And with that, we have 4 minutes for questions, but thank you very much.